Hello everybody, this is Mohammed from Chalmers University of Technology. Today in this video I will talk to you about optimizing retrofitting measures and concentrating on wall and windows retrofit. The outline of today's video will be I will give you a short introduction and then the scope of the work. Third there will be research question. Why do we carry out such research and what is our objective? Fourth will be explain the developed model, and I will end with conclude. Introduction. To improve the performance of an existing building in terms of energy use, retrofit measures are applied. We can improve the thermal performance of the building by adding insulation to the roof or adding insulation to the floor, adding insulation to the external wall, improve windows quality, and etc. The scope of this study, the case study or the apartment considered or the house considered in this study is an apartment in a multi-store building. This means that there is no thermal load from the floor or there is no thermal load from the roof. Consequently, retrofit external shell of the building means improve only the thermal performance of wall and windows. Since there is no heat load or thermal load from the roof or from the floor, we will concentrate only on the wall and windows. Retrofitting the external wall is done by adding insulation to the wall, as we can see here. It can be in different shape or different construction. For in this picture, for instance, we can see sandwich construction. We have internal and external wall layers, and between them we insert insulation. While retrofitting windows is by choosing window with a lower U value, more glazing layers with a better frame, with thermal break in the frame, and different construction of the window, so the U value of them is getting lower. And research question. In this work, we were trying to answer a question as the following: if I have a certain amount of the money, what is the optimal use of this money to improve the thermal performance of the wall and the windows U value to achieve the maximum annual saving for a given certain budget? So the first research question is, what is the optimal use of a given budget to achieve the maximum annual saving? Now, the opposite scenario. Let us assume we need to achieve a certain annual saving. And what is the optimal retrofitting measure for the wall and the optimal retrofitting measures for the window, and to minimize the required budget? So the second research question is, what is the required budget to achieve a specified annual saving target? As mentioned before, to answer the research question, a computer model was developed. The interface of the model looks like as shown in the screen. We have input section where we can put some information related to the location, related to the dimension of the building, the specification of the external shell of the building, indoor conditions, and also internal load due to lighting, refrigeration, applicants, and due to people there, the height of the building, and also how much we have for retrofitting, and also how much we need to save, the saving target. In a results section, we have the most important results are in this column. The heating load, cooling load, annual heating cost based on the electricity price, annual cooling cost based also on the electricity price and based on the COP of the heating cooling system. In our case, we assume that the COP of heating system is 2.2 and for cooling system is 2. You can put any number you have in your case. Also, in the result section, we can see the cost of improving the external wall by adding insulation, the cost of improving the window quality, the total cost and annual operation cost, and lifetime operation cost and retrofitting. So the lifetime, it depends on the present worth factor, which depends on the years or lifetime of the project. I need to calculate the lifetime operation cost during 20 years or 10 years or whatever you want. So you can say how much you can see how much you can save during a certain lifetime of the project. Also, we have input related to air temperature, and we can get this information from metronome, as I mentioned before in my previous video. So easily we can bring the available solar energy in horizontal surface and outdoor air temperature from. After we insert all input data in our model, we can run the calculation and by pressing F9, and then we get the. So in our case, if the U value of the external wall is 1 and the U value of windows are 2.5, then this is the heating and cooling load, and this is the cost. This is the operation cost, annual operation cost. And in 20 years, this is the cost will be about 36,000. So my house or my apartment, my building will cost me for heating and cooling during 20 years. I choose 20 randomly, 20. You can choose any year. Will cost me about 36,000. Now I can specify the available budget. I need to assume consume for example in this example I show here. I need to spend 17,000 or $17,500 to retrofit my building. What is the optimal use? How much should I consume on windows and how much I should consume or spend on walls? Just by, as I mentioned, put the available budget and we press this button. Then the model start calculating. It takes 2-3 minutes, so I will stop. So the calculation is completed and the results are reported in this table. No insulation before retrofitting. This is the best insulation for different direction of my external walls. This is the U value of my window, so I have to retrofit my window from 2.5, assume it at the beginning, to 0.9 of the northern wall. For eastern wall, I can keep it as it is. For the walls faces the south, I need to retrofit it to this value, and also for insulation here. So by spending this money I specify at the beginning, I can the operation annual operation will be reduced from 2,300 to 1,200. So by spending this amount, I will save 47% of my annual operation cost. And my system will cost me, even though I spend this much of money for retrofitting, the operation cost during 20 years will be almost the same. So I spend money, yes, but I save annual operations, so I will get my money within 20 years. And by sudden, I just put 20 numbers, so I get the same number here. 20 years, so I get the same number. This is first research question. I have a certain amount of money. What is the optimal use? The computer told me where should I spend money? I should spend this much on wall. I should spend this much on windows, and on the wall I should spread them in, as we can see here in these numbers or this column. On the window I should spend the money 3,500 as shown here. I will reduce my annual cost by 47%. To answer the second research question, which was if I need to achieve a certain saving in annual operation cost, how much how much money I need to spend on retrofitting. So the only way the model was developed to answer this question by clicking this button, which will take 10 minutes or 12 minutes to finish. So I did that previously, and we get this table, and the answer or the numbers are illustrated in this figure. So to achieve here, we can see different saving target. For instance, if I need to achieve 40%, I need to spend about 12,500. If I need to save 20%, I need to spend about 9,000, and so on. This is what the model can do. This way we answer the research questions. What is the optimal use of a given budget to achieve the maximum annual saving? We saw how much we need to spend on the wall, how much we need to spend on window, and how much we will save due to spending a certain or specified budget. And the second research question was, what is the required budget to achieve a specified annual savings? So we saw from that figure for specified for or specific annual saving, we how much we saw how or the model calculated how much money we need and what is the best use or the optimal use of that money. Thank you for watching, and I'm sorry if it was a little bit long video.